So, need to do some little additional notes on graphing inequalities. Just again, graphing inequalities for parabolas. It's the same thing for lines. So, for instance, let's start with that. If I have a line and it says y is greater than whatever the equation of this line is, then I'm going to shade above it. Greater than, y is greater than means above. Y is less than means below. It's as simple as that. It's the same thing for parabolas. Above the parabola would be the part that's up here, of course. So that would be y is greater than, and y is less than would be everything else around the outside of it. So if you have two of these things going at the same time, like y is greater than the red one and y is less than or equal to the blue one, and I'll put a blue one over here, what I usually do is I look at all the different areas of this that are divided into this graph. For instance, this has 5 different regions, okay? And each of the regions that we talk about here, we've got regions that are above the red one and below the red one, above the blue one and below the blue one. So if we ask for both of them at the same time, we're looking for the regions of intersection. So one way of looking at this is to say if I was just to look at the red graph here, y is greater than the red graph would be all the points that are in region 2 and region 3. And then if I look at all the points that are below the blue one would be this section in here, which would be sections 3 and 4. We can see clearly that region 3 is in both of these. It satisfies both directions. It's above the blue one, above the red one, but below the blue one. So if you're asked to graph this, you would be just shading in region 3, and you wouldn't do all that other shading. You could, but it's really not helpful because the solution for this system is region 3. So let's do the same thing again, except let's change the things so that it's less than the red one. And I'll keep the same type of graphs, and greater than the blue one. And by the way, I can do it like this, and remember that if it's just greater than, it's going to be a dotted parabola, because dotted, if it's not equal to, it means that it doesn't reach the border of that blue one. So let's see whatever the numbers of the regions are, like this. So I would say the same thing. All the points that are below the red graph, inside the red graph is 2 and 3. Obviously, they're above the red graph. So everything else, 1, 4, and 5, are below it. Right? So 1, 4, and 5 are below it. And greater than the blue one, well, the blue one is over here, and 3 and 4 are below it. So 1, 2, and 5 must be above the red graph. So if I look and see where they intersect, I've got region 1 and region 5. 2 is only in the blue one. 2 is only above the blue one, and 4 is only below the red one. So the way I would graph this one, or the way I'd shade it, would be region 1 and region 5, because they're in both graphs. So that's just a little bit about graphing combined inequalities with parabolas. Of course, you could have parabolas that look like this, or they could both be pointing down, or all sorts of different ways that parabolas can be.